Electricity. It's a part of our busy lives every day. With just a flick of a switch or the press of a button, electricity helps us greet the mornings. It helps see us through the day, at home or at work. And electricity helps us unwind at the end of a long day. It seems like electricity has always been with us. It's something we take for granted. But did you ever stop to think about where electricity comes from? In basic terms, the electricity which you use every day comes from a generating station, much like this one, the William H. Zimmer generating station. The process begins with coal, fueling a huge furnace. The rising temperature heats water, producing steam. The steam, in turn, propels a turbine and a generator. The result is electricity. But of course, the production of electricity in CG&E's generating stations is neither a simple or a small-scale process, and there is no generating station in the world like the William H. Zimmer station. The construction of this station and the generating of electricity from coal is both a complex and a fascinating demonstration of the latest in technology. We invite you to come along and get to know the Zimmer generating station and its people a little better. While each CG&E generating station has its own unique story, the William H. Zimmer generating station here on the Ohio River in Moscow, Ohio, is truly a one-of-a-kind place. It is the world's first conversion of a power station from nuclear to coal-fired capabilities. It is a generating system so technologically advanced, energy experts from around the world have been traveling to see it. The Zimmer story takes us back to the year 1971. Construction was underway on the first of two proposed nuclear units. In 1984, all construction on the nuclear project was halted, and the decision was made to convert the station to coal. The coal-converted station now provides 60% more power than the planned nuclear unit. No coal-fired generating unit is more powerful than Zimmer. And Zimmer Station operates with the industry's most advanced environmental equipment so that the station will meet all aspects of the 1990 Clean Air Act. Zimmer is also a construction marvel. The station was built on half the land of comparable stations using an innovative idea, modular construction. Many large components were built off-site and brought to Zimmer on trucks and barges. One of the world's largest cranes, the Lamson Translift, was brought to Zimmer on 120 tractor-trailer trucks, assembled on site, and then used to hoist loads as large as 500 tons into place. The electricity life chain at Zimmer is also a one-of-a-kind story. It begins here with the unloading of coal from a barge. Barges move along the Ohio River to Zimmer, each one carrying up to 1,500 tons of coal. The unloading process is completed by the coal barge unloader. This continuous bucket-type unloader can transport up to 2,500 tons of coal to the conveyor system each hour. The coal conveyor system provides the method of travel. It routes the coal either to the station or the reclaim storage pile. The reclaim pile is used to keep a 30 to 90-day supply of coal, just in case there's a malfunction of the coal barge unloader, or in case barge traffic cannot reach the station. The usual route takes coal to the station's coal silos, where it meets the pulverizers. Zimmer is fitted with 14 pulverizers, each capable of grinding up to 140,000 pounds of coal per hour. Normally, the station burns 530 tons of coal per hour at full load operation. The coal is crushed to a fine powder, much like the consistency of face powder. Air enters the pulverizers from the bottom, where it picks up and warms the coal powder, transporting it to the boiler furnace. There, coal burners work to ignite the coal. As the coal is burned, temperatures in the furnace rise, reaching 2,300 to 2,600 degrees Fahrenheit. During a normal day, this unit will burn 12,000 tons of coal. Before continuing with the Zimmer steam cycle, let's talk a little bit about the byproducts of the coal burning process. As a result of burning coal, ash and hot exhaust gases are produced. To deal with the coal-burning byproducts, special environmental control equipment was put into place. Zimmer Station was built to meet or exceed all government environmental standards, making it one of the cleanest coal-fired stations in the country. In fact, about $350 million went into facilities to protect air and water quality. Approximately 16% of the station's daily operating costs are associated with environmental control equipment. Most of the ash, or fly ash, is carried through the furnace by the hot exhaust, or flue gases. The heat from this gas is used in several ways before exiting the stack. It's used to superheat the steam to 1,000 degrees Fahrenheit. It also heats water returning to the furnace and is used to preheat incoming combustion air. All of these uses improve the efficiency of the system. To limit air pollution often associated with coal burning, two state-of-the-art pollution control processes work together at Zimmer to deal with the exiting flue gases. Equipment called an electrostatic precipitator, which works much like a giant electronic air cleaner, collects 99.8% of the fly ash particles from the flue gas before they enter the flue gas desulfurization or scrubber system. About 60 tons per hour of fly ash is removed at full load, depending on the coal being burned. The second unique environmental control here is the flue gas desulfurization system, which is known as the scrubber. Huge fans supply the scrubber system with gas from the precipitator. Lime slurry is sprayed into this flue gas in the absorber modules, where more than 91% of the sulfur dioxide, or SO2, is removed from the gas stream. The flue gas, along with almost 1,600 gallons per minute of water vapor, then flows from the scrubber to Zimmer's 573-foot stack. The lime used in this process is brought into the scrubber system in much the same way the coal is. Lime is unloaded and placed on a conveyor. A uniquely designed barge unloader is used to cut down on the lime dust. Over 800 tons of lime is used each day to scrub and stabilize the removed SO2 product. Meanwhile, fly ash from the precipitator and SO2 product from the scrubber are transported to the waste stabilization plant to be mixed, processed, and taken to the landfill. Let's return now to the Zimmer steam cycle. As coal is burned in the furnace and the temperature rises to nearly 2,600 degrees, water circulating through the surrounding tubes within the furnace turns to steam. Every hour, nearly 10 million pounds of steam are heated to a temperature of over 1,000 degrees Fahrenheit. This superheated steam is sent at 4,000 pounds per square inch to propel Zimmer's turbines. First, the steam pressure drives the high pressure and intermediate pressure, or reheat, turbines. Next, exhaust steam is used to spin low pressure turbines. The steam-driven turbines then drive the generators. This high-pressure, high-temperature steam cycle process at Zimmer, known as a supercritical cycle, makes Zimmer's steam cycle more efficient than standard superheated steam boiler cycles. At full capacity, Zimmer is capable of producing 1,300 net megawatts of electrical power. The amount of power a generator produces is measured in watts. To get an idea of how much power a watt is, think about this. This light bulb uses 100 watts. 1 megawatt equals 1 million watts, or enough energy to power 10,000 of these light bulbs. Because electricity cannot be stored, it must be produced at the same instant you use it. From our station to your home or office, power generated at Zimmer travels at 186,000 miles per second. At that rate, you can travel around the Earth 7.5 times in 1 second. Now, let's finish the electricity cycle. Once the steam has passed through the turbines, it enters the condenser, where it is cooled. The cooling process turns the steam back into water. From there, the water is returned to the boiler, where the cycle is set to begin again. The condenser is cooled by water circulating from a cooling tower. The water from the bottom of the cooling tower goes through the condenser in tubes, which keeps it separate from the steam. The water then returns to spray headers in the cooling tower, where the water's excess heat is removed by evaporation. Over 8,000 gallons of water is evaporated out of the top of the tower each minute. This water is replaced by drawing fresh water from the Ohio River. The cooling tower, which is just the right size to fit inside the playing field of Riverfront Stadium, is actually an environmental protection device. The unique shape creates a natural draft where the hot air rises faster, drawing more cool air in the bottom. The tower uses no electricity to cool the water. This evaporation process allows the plant to reject its heat to the air, not to the river, where the warmer water could affect fish and plants. Lab technicians perform routine water tests, making sure any water returned to the river meets or exceeds all environmental standards. The mouth of the Little Indian Creek, located on the Zimmer site, was preserved in its natural setting to allow for the continued spawning of fish and to help maintain the balance of nature. The William H. Zimmer Generating Station, an engineering marvel and an environmental pace-setter. The experienced and highly trained Zimmer team, utilizing the latest in technology available and a rigid regime of quality control checks, make it all possible. The Zimmer Station is part of CG&E's continued commitment to the service of the greater Cincinnati area. As our community continues to grow, the need for Zimmer Station becomes even greater. Zimmer Station, generating our electrical needs today and poised to provide generation for future generations. Thanks for taking the time to get to know us better. We hope you enjoy your day at the William H. Zimmer Generating Station.